स्टूडेंट्स, आज के क्लास में हम लोग लैंग्वेज ऑफ केमिस्ट्री, जो बेसिक ऑफ केमिस्ट्री है, जो बिगिनिंग ऑफ केमिस्ट्री है, वो हम लोग स्टडी करेंगे, हैविंग हेडिंग एटम्स एंड मॉलिक्यूल्स। स्टूडेंट्स, ये चैप्टर जैसा हमने बतलाया बेसिक कॉन्सेप्ट के लिए है। इसमें बहुत सारे जैसे सिंबल, फॉर्मूला, वैलेंसी, मेथड ऑफ राइटिंग फॉर्मूला ऑफ डिफरेंट कंपाउंड्स, टू फाइंड वैलेंसी ऑफ द एलिमेंट फ्रॉम द गिवन फॉर्मूला एंड अदर टॉपिक्स हम इसमें पढ़ेंगे। सबसे पहला पार्ट है कि जिससे हम लोग बात करते हैं मैटर की। व्हाट इज मैटर? In general, we say that matter is anything which has mass and occupies a space. Anything which has mass and occupies a space is called matter, and it can be perceived by our senses, sense organs, means which we can touch, we can see. These are called matter. Matter is of two types generally, that is, in which there may be pure substance and impure substance. Now here we study about first point, that is the pure substance or element, and then we will come to study about the atom. Now element is the pure substance, which cannot be broken down, into further simpler forms, and consist of only one type of atoms. So this is the pure substance which cannot be broken down even by any method into further more simpler forms. Like you see, suppose we take a piece of gold. Whatever may be the smaller particle made from it by breaking into pieces, even the smallest particle of it will have the property of gold. That is, we cannot obtain another simpler forms from it. So it is a pure form. Now we have written here that is consists of only one type of atom. Now what is atom and how was it studied? Then students, we see that for the smallest particle of any matter, the first term was used as Parmanu by our Indian philosopher, that is Maharishi Kanad. So here we see that is Maharishi Kanad used the term Parmanu for the smallest particle of matter. It was later on known as atom. So it was Democritus used the term atom for it. Democritus used the term atom. Now later on it was John Dalton who gave its own postulate about it. Now just you see, that is, what is now an atom? Atom. As we know, we will study about Dalton's atomic theory again, which is also studied in atomic structure chapter. Atom is the smallest particle of an element. The smallest particle of an element which may or may not exist independently but can take part in chemical reaction, in a chemical reaction. Means, according to the atomic structure, if an atom has 2 or 8 valence electrons, 2 for helium, that is the duplet for the first orbit, or 8 valence electron, then it is chemically inert. It does not take part in chemical reaction. So that can exist in free state, independent state. So here may or may not. But if an atom has incomplete valence shell, means which has not completed duplet or octet, will not be stable, so it always combines with another similar atom or atom of different element to change into molecule that will be stable now. So it is said that it may or may not exist independently but can take part in chemical reaction. Now students, we see here, that is, atom is the smallest particle of an element. Now just this is the atom. Many scientists gave atomic theory, one of which was the ancient John Dalton, who gave atomic theory. According to Dalton's atomic theory, there are some main postulates. According to Dalton's atomic theory, we know that atom is the smallest particle of every matter. This was the first point which was discussed by earlier philosophers or scientists also. Second, an atom is the indivisible particle, smallest particle. But as we know that discovery of electron, proton and neutron shows that atom can be further divided. Next, atoms of an element, all atoms of an element are similar in all respect. But as we know that atoms of isotopes are the atoms of the same element but have the different mass numbers. So they are not similar in all respect. So discovery of isotopes shows that atoms of the same element may be different from each other in their mass. Atoms of different elements are different in all respect. But again, the discovery of isobar indicates that atoms of different elements can have the same mass number. Although they have the different atomic number, but they will have the same mass number. So this was the next point. Next point of Dalton's atomic theory. Atom can neither be created nor be destroyed, nor be destroyed. But again, the discovery of nuclear reaction like nuclear fusion and nuclear fission, we know that atoms can be created or destroyed. Like in nuclear fusion, when two lighter nuclei fuse, a heavy nucleus is formed, heavy atom is formed, like hydrogen fused to form helium. Similarly, in nuclear fission, a heavier atom of radioactive substance, when bombarded with slow moving neutron, split into two lighter nuclei and new element is formed. For example, when uranium atom, uranium 235, that is uranium having atomic mass of 235, when bombarded with slow moving neutron, it breaks into barium and krypton like lighter nuclei. So this one is again denied by modern researches, modern atomic theory. Next, that is atoms of different elements combine to form molecule of a compound. So just you see, students, that is, this was the point given by Dalton, is still accepted by us, still useful to us. But although these points were denied, but Dalton gave us wide area, wide points for the further study or for the next discoveries. Now, so this was the introductory part of the atom. Now you see, students, when elements, that is according to the sixth point of or last point of the Dalton's atomic theory, that atoms of different elements combine to form molecule of combined indefinite ratio to form compound or molecule of compound. Now you see, there are some laws of chemical combination. Chemical combinations, यानी in order to describe, यानी डाल्टन्स एटॉमिक थ्योरी के लास्ट पॉइंट को समझने के लिए हम लोगों को दो पॉइंट्स यहाँ दिया हुआ है, दो लॉज दिया हुआ है. बहुत आसान पॉइंट है ये, बहुत कॉम्प्लेक्स नहीं है. पहला है लॉ ऑफ कंजर्वेशन ऑफ मास. लॉ ऑफ कंजर्वेशन ऑफ मास. According to this law, matter is neither created nor destroyed during a chemical reaction. Means, if a reaction is taking place, then the total mass of the reactants is equal to the total mass of the product formed. That is, this is the conservation of mass. That is, the mass or matter is neither created nor destroyed in a chemical reaction. Chemical reaction means, suppose we take example. In that case, suppose we see that, suppose here is the example, Mg plus O2 gives us MgO. Now the equation should be balanced, because if there are two atoms of oxygen, then on the product side there must be two atoms of oxygen. So we write here 2, and if there is 2 atoms of magnesium, here we write 2. Now come to calculate the mass of reactant and products. Here we see 2 multiplied by, The atomic mass of magnesium is 24. Its atomic number is 12, but mass number is 24. So this is 24, that is 48 gram. Here 16 into 2, 32 into 2, sorry, 16 into 2. The atomic number of oxygen is 8, but mass number is 16. So it is 32 on this side. Twice 24 plus 16, that is 2 into 40, hence 80 gram. Now overall if we will study here, 48 plus 32, hence 80 gram, and here also there is 80 gram. So the mass of reactant is equals to the mass of the product. Thus this shows that during a chemical reaction, matter is neither created nor destroyed. Therefore an equation, while writing a chemical reaction, representing a chemical reaction, the equation should be balanced also. We will later on again study it while studying the chemical reactions and its balancing. Now this was first law. The second law is law of definite proportions. Definite proportions. According to this law, it says that atoms of element always combine in a definite proportion by mass to form molecule of compound. That is, whatever may be the source of that compound, the composition will always remain constant. That is, now here we see that atoms of elements combine in definite proportions, by mass to form molecule of compound. Definite proportion. Now in this part you see, for example, जैसा कि अभी हम बताया आपको कि हमारा सोर्स कहीं कोई भी हो, हम कोई उस पार्टिकुलर मैटर को कहीं से ऑब्टेन करते हो, लाइक सपोज यू टेक वाटर, प्योर वाटर, whether it is taken from sea, from river, from well, or from any other part. Whenever we take water, if we take water molecule, that is water molecule whose formula is always H2O, that is 2 atom of hydrogen plus 1 atom of oxygen. If we will take its mass, then 2 into 1 plus 16, hence it is 2 plus 16, that is 18. Means every 18 gram of water will contain 2 gram of hydrogen and 16 gram of oxygen. So the hydrogen and oxygen are in the ratio 2:16, hence it is 1:8 by mass. That is, whatever may be the source of compound, the composition, the mass of the elements involved will always be in a fixed proportion. तो आप देख सकते हैं कि आप वाटर कहीं से भी ले आएंगे, आपका प्रोपोर्शन, रेशियो ऑफ द एलिमेंट्स इन्वॉल्व, दैट इज हाइड्रोजन एंड ऑक्सीजन, विल ऑलवेज रिमेन कांस्टेंट. सो दिस इज नोन एज द लॉ ऑफ केमिकल कॉम्बिनेशन. नाउ स्टूडेंट्स, जब स्टडी स्टार्ट हुआ, एटम्स वेयर डिस्कवर्ड, डिफरेंट एलिमेंट्स वेयर डिस्कवर्ड, In order to represent in chemical reaction, how do they combine? The representation was essential. Combination was required to be represented. In the beginning, scientists like Dalton, used different symbols to represent the name of the element. Like the symbol, the heading is symbol. Now Dalton used some symbols for to represent elements. Used pictorial symbols for elements. Example, for hydrogen he used this symbol. For carbon he used circle, which is shaded. For oxygen he used hollow symbol, hollow circle. Similarly, for sulfur he used this symbol. For phosphorus he used this symbol, and so on. So he used some symbols to represent these elements. But while writing the formula of compound or a chemical reaction, the representation of that compound or equation using these symbols was quite difficult thing. So later on, further another method was used by taking the letters from the name of the element. One or two letters from the name of the element were taken to represent the symbol or name of the element. So now what is symbol? Students, now it is the symbol which has to be defined. Now you see, the symbol is the short form representation of the name of element taking one or two letters taking one or two letters from its name. Generally we take Latin name for it, but sometimes we also use that is its other name, or that is simply we can take a form of its name. Now you see, for example, there are many elements, like you see, suppose we have carbon, then its symbol is taken as C. Suppose we have calcium, then since we have used the letter C, so we will take here Ca. Now suppose we have cobalt, we take CO. If we take, suppose, chlorine, it is represented by taking this one. Similarly, if we have sulfur, it is S, phosphorus, P. Similarly, we can take oxygen, O, and so on. But there are some elements whose name does not, or whose symbol does not come from its English name, but we take it out from its Latin name. That is, suppose we take Suppose we take sodium. Then we do not take its symbol from here, but its Latin name is natrium. Hence we take the symbol Na from here. Potassium. Potassium. It was taken from kalium. Hence Ka. Similarly, suppose we take silver. Silver. It is taken from argentum. Argentum, that is Ag. Iron, from ferrum. It is taken as Fe. Similarly, students, there are many other symbols also. For example, more symbols. Suppose we take mercury. Its name is hydragyrum. Hydragyrum, hence Hg, and so on. So these are the symbols of some of the elements taken here. Now, students, as you will proceed, as you will study further, more and more elements and their symbols will come to you. Now, what is the significance of symbol? Significance of symbol. Two basic points are given here, that it represents name of element. Name of element. As we see the symbol, for example, if here it is written C, immediately we say that it is carbon. So it represents the name of the symbol element. Second, it represents mass of element equal to its atomic mass or gram atomic mass. We'll also later on study mass. Well, one point can also be taken, which we'll also study in later topics, that is, it represents 1 mole of element, 1 mole of atoms of element. 1 mole of atoms of element. We will later on discuss it in detail. For example, suppose the symbol of an element is C. Then what will it represent? It represents element carbon. First thing, that is the name of the element. Second, it represents 12 gram of carbon. The atomic mass of carbon is 12, or gram atomic mass of carbon is 12 gram. So if we write C, it means that it represents 12 gram of carbon. Suppose at any place, if we write 2C, means it represents 2 into 12, hence 24 gram. So this one represents its atomic mass, as well as it represents 1 mole of carbon atom, and so on. So by using the symbol, we can have these 3 basic informations. So students, now you do understand about the symbols of elements. How are these symbols taken? From English name or from its Latin name, using 1 or 2 letters from its name. Now, its significance has also been studied. So students, in next part we will study about the molecules its significance, and then the other related topics.